we need to figure out where this piecewise function is continuous. I'm going to draw your attention to a couple points, namely -3 and 5. These are what I call junction points because they serve as the branch connecting this piece of the function to this piece of the function. Same thing for 5 as well. All I need to do is take this junction point and plug it into the pieces that it belongs to, making sure that they match. So when I take -3 and plug it into both pieces, I get the following. 6 minus -3, that's going to be 9. When I take -3 and plug it into x squared, that also gives me 9. So I can be pretty sure that, well, I'll say one last thing about why I'm not totally sure. I'm pretty confident that it's continuous at x equals -3. One last thing you got to check is to make sure at least one of these two signs has an or equals to on it. And since this one does, we're good. So we're safe at x equals -3. Now how about at x equals 5? When I plug in this junction point into these two pieces, let's see what I get. 5 squared is 25. 20 plus 5 is also 25. So x equals 5 is also safe. So with that in mind, this seems to be continuous everywhere. I didn't worry about it being continuous at any other value of x. It was just at these particular weird values of -3 and 5 where I thought this graph might be discontinuous. And so as a result, it's continuous everywhere.